Hello everyone, this is Amritpal Singh. Welcome to the next video. This is a CNN part 2 video. In my previous video of CNN part 1, I've already explained what is CNN, what happens over there, right? What's the basics of CNN? We talked about a lot of things like input images, filters, then we talk about feature maps, right? This thing I already have covered. Just to make a connect to this video, I'm again just give you a little summary of what we discussed in the previous video. In a previous video, we discussed about these components of CNN in which we have an input image available. We have this function called convolutional function. Then we have this feature detector. We also call it as a filter or kernel. Then we are getting the feature map available, right? So we have already discussed that how we are able to reduce from the these dimensions of the image to generate the feature map. And further we discussed already that how we are able to generate a lot of feature maps from this input image, because I've told you that these feature maps are generated by applying different filters. Okay, so this is, like, suppose this is the this feature map we got from a one filter, this is which is shown in this this slide, and the next feature map is created with the another filter, and so on. Why? Because like we may lose some information. Just to preserve the information, we are applying a lot of filters here, right, to generate the layer of this convolutional layer. So what happens after that? Today we are talking about the another next step, which is called ReLU. So ReLU, which is a rectified linear unit. It's an additional step on top of the convolutional step. So what is going on here? Well, we are having an input image, we are having our convolutional layer, that which we have already discussed. On top of that, we are going to apply the rectifier function. And the reason we are applying the rectifier is because we want to increase the non-linear in our image, non-linear thing in our image or in our network, and rectifier act as an filter or act as a function that breaks up this linear thing, right? We want to increase the non-linear thing in our image, and this rectifier function which breaks up the linearity, right? And the reason we want to increase this non-linearity in our network, because images themselves are highly non-linear, especially if you are recognizing different objects next to each other, or just backgrounds and stuff like that. The image is going to have lots of non-linear elements, and the transition between pixels, adjacent pixels, is gonna be non-linear. And that's, you know, that because there's a borders, there's different colors, there are different elements in your images. At the same time, when we are applying mathematical operations such as convolutional and running this feature detection to generate our feature maps, right, we risk that we might create something linear, and therefore we need to break up this linearity, right? So let's before we move to the example, let's discuss this mathematical definition as well, which I've already have explained in one of my video, like in which I've explained the different activation functions used for artificial neural networks. And one of the popular rectifier function is this one, ReLU, the rectifier linear unit. It's a mathematical definition. In this case, they have explained for any input x, ReLU returns x if x is positive and 0 otherwise. Let's take an example now. Here's an image. It's an original image, right? It's an image we're gonna take today as example. It's an original image. Now, when we apply the feature detector to this image, we get something like this, right? This is the this we got after applying the feature detector. Okay, so you can see here the black is negative and the white is positive values. Well, when you apply the feature detector to this proper image, which has not just zeros and ones but lots of different values, feature detector can have a negative values in themselves. Sometimes you will get the negative values, and here or there black ones are negative and white ones are positive. And what a rectifier linear unit does is it remove all black, right? This is what we get after applying the ReLU, right? I'm again repeating, this is our original image, this we got after applying the our feature detector, and this we get after applying the ReLU, this rectifier unit function, right? So so it removes all the black, right? Anything below the 0 turns into 0, and from this it turns into this, right? So it's pretty hard to see what exactly is the benefit in terms of breaking up this linearity, which I was talking about. I'll try to explain, I'll just show an example on this image, but at the end of the day, it is a very mathematical concept, and we have to go into a lot of math to really explain what is going on. But let's have a look. Let's, for instance, right, let's look at this building here, right? So this is a building on its own, and then you can see its shadow, this black part, this one, this black part, this shadow over there. Well, you can see that it's white, right? The reflection of the light, and then it's gray, and then it gets darker, and it gets darker again, right? So when we take it out, we take out the black part. So just think in the terms of linearity, right? So let's look like when you go from white to gray, the next part would be black, right? So next part would the next part would be black. It's a linear progression from bright to dark, right? And therefore this is kind of a linear situation. When you take out the black, like in this case, you break up this linearity, right? This is what happens when you apply the rectifier, this ReLU function on this convolutional layer. I hope you must have understood the next step, what follows the convolutional step from this short little video. In my next video, I'll be explaining the next step, what is going to happen after this rectifier function step, right? Thanks for watching, guys. See you next video.